Hello and welcome to this presentation on retrieval-based learning. Retrieval-based learning is a study strategy that enhances durable memory and deepens understanding of course content by actively engaging in retrieving knowledge rather than passively exposing oneself to material by rereading. It is especially important that students in medical education learn this strategy due to the immense volume of information they are responsible to learn within a limited amount of time. Can you identify the picture of the actual penny? Most people are surprised at how difficult this exercise really is. After all, we've looked at this coin thousands of times. Shouldn't we be able to find it easily? Not really. This exercise sheds light on how we must actively practice what we know rather than passively observe. Simply observing a penny thousands of times is akin to using rereading as a learning strategy. So how could you have prepared for this exercise? We will explore this question later in the presentation. There are two main principles of retrieval-based learning. They are spaced retrieval practice and interleaving. Let's explore these in further detail. Let's talk about spacing first. When we space out practice at a task and get a little rusty between sessions, retrieval is harder and feels less productive, but the effort produces longer lasting learning and enables more versatile application of it in later settings. Students often ask me, what is the ideal amount of time to allow between practice sessions? That varies. The answer is the point of almost forgetting. Retrieval is the act of self-testing or practice teaching the material. Retrieval practice is a more effective learning strategy than review by rereading because it actually interrupts forgetting. Each time we recall something, the neural pathway is strengthened, enabling us to access that information again at a later time. Interleaving is essentially mixing up one's practice. Often students describe this strategy as doing a little bit of everything every day. Interleaving by varying topics of study produces better application and discrimination. We are better able to compare and contrast when we practice related topics in close proximity. Interleaving also creates spacing. This principle is the opposite of massed practice, or cramming, as we more commonly refer to it. So why don't students naturally practice retrieval-based learning if it's so effective? Because learning is counterintuitive. Rereading text and mass practice of skill or new knowledge are by far the preferred study strategies, but they are among the least productive. Rereading and massed practice makes us feel as though we are learning, but only because of the growing familiarity with the content that they produce. Would you have guessed that identifying the penny would have been such a difficult task? We are all susceptible to illusions of knowing. That growing familiarity that's created by rereading can lead to overconfidence in the material. Testing helps calibrate our judgments of what we've learned and should be used as a tool to identify areas of weakness. Let's now talk about a study that was conducted by Jeffrey Karpicki of Purdue University. Dr. Karpicki gathered undergraduate science majors to test the efficacy of retrieval-based learning. He divided his participants into 3 groups. Each group would have 4 study sessions to learn the material presented in a science-based text. The study sessions for the first group, SSSS, consisted of reading and rereading the text 4 times. The second group, SSST, read the text in sessions 1 through 3, and in the fourth, this group was asked to write everything that they could remember on a blank piece of paper. The third group, STTT, read the text in the first session, and in each of the following sessions, they recorded what they could remember on a blank piece of paper. 5 minutes following the 4th study session, the participants were tested. The graph on the left shows the results. The SSSS group remembered the most, while the SSST group remembered the least. However, there was not a significant difference in their scores. 1 week later, the participants were retested. As you can see in the graph on the right, the STTT group scored significantly better than the SSSS group. What is most remarkable is the comparisons of how much forgetting took place for the SSSS group. This study illustrates the effectiveness of retrieval-based learning. Retrieval practice resulted in more durable memory. Of interest was the student predictions of learning, which were assessed after the first test. The SSSS group was the most confident in their ability to remember their learning 7 days later, while the STTT group was the least confident. Illusions of knowing result from our tendency to mistake fluency with a text for mastery of its content. Students who study by rereading their texts can mistake their fluency for possession of accessible knowledge and overestimate how well they think they will do on a test. So how do students practice retrieval-based learning? By self or partner quizzing and teaching. For quizzing, pause periodically to ask, what are the key ideas? What terms or ideas are new to me? How would I define them? How do the ideas relate to what I already know? And how can I summarize this concept in my own words? Use questions that are provided as tools for learning, not measures of studying. It is never too early to engage with test questions. When we start with a question and later learn the answer, we are more likely to form a durable memory. If no questions are provided, generate questions and work with a partner to solve them. Be sure to quiz regularly on content material and material covered in weeks prior in order to build repetition, and always check your answers to provide feedback on your progress and refocus on your shortcomings. For teaching, start with the lecture objectives and articulate your explanations. Draw or write on a dry erase board as you are talking. If you're working with a partner, take turns questioning assumptions and providing feedback. Even when studying alone, practice teaching is essential. Study in a room where talking is allowed and a dry erase board is accessible. So how could we apply the principles of retrieval-based learning to the penny exercise that we discussed at the beginning of this presentation? Before the test, we could have talked about the features of the penny with a partner and established the significance of each of the elements. Next, we could have practiced drawing the penny or quizzing about its features. We would have done this multiple times that were spaced apart, perhaps each morning for several days. Before selecting the correct penny, we would have talked out or drawn a correct image. Finally, we would have matched our description or drawing to the correct choice. So, do you think you know the image that represents an actual penny? If you selected A, you were correct. Take a look at William Glasser's theory of study strategy efficacy. We remember 10% of what we read, 20% of what we hear, 30% of what we see, 50% of what we see and hear, 70% of what is discussed with others, 80% of what is experienced personally, and 95% of what we teach to someone else. So remember, intuition tells you to reread because fluency makes you feel like you are learning. Quizzing and practice teaching arrest forgetting, provide a reliable measure of what we have and have not learned, and strengthen our learning. A habit of disciplined space retrieval practice eliminates the need to cram. For more information on retrieval-based learning, Check out these resources. I hope that you've enjoyed this lesson and made connections to your own study strategies. If you would like to further discuss how to incorporate retrieval-based learning into your practice, please feel free to contact me by email, phone, or stopping into the Division of Student Affairs and Inclusion.